Question 9, increase 100 by 12%. Now, there's two ways of looking at this. You could think, well, this is easy, I'll just do it in my head, but it's only easy because it's an easy number of 100 that we've been given in the first place. So 12% of 100 is just 12. So basically, you are increasing 100 by 12. So increase 100 by 12, your final answer would be 112. However, it wouldn't be so simple if this wasn't 100, if it was like 99 by 12% or 87 by 12%. So we really need to think about what we call decimal multipliers. So we're going to have a little chat about those. So when you're increasing anything by 12%, what you're actually doing is you're taking the original value, which is be 100%, but that could be anything. So if your original value was 87, 87 would be classed as your 100% value, your starting value. And you'd be increasing it by 12%, which would give you 112%. And as a decimal, 112%, you basically just move the point in two places, or in other words, divide by 100, your decimal would be 1.12. So to increase any number by 12%, you can times by 1.12. And this sort of thing is normally on a calculator paper as well. Certainly, if you had a harder number like 87 by 12%, you would do 87 times 1.12. Let's try another one. So if you are increasing by 23%, then your decimal multiplier would be reached as follows. So you would go, the original number is 100%, you're adding 23%, so that leaves you with 123%, and as a decimal, 123%, move the point in two places, divide by 100 is basically 1.23, so you would times by 1.23. If you were increasing by something less than 10, a percentage less than 10, so for example, increasing by 7%, some people think you can just put the 1 point in front. So 12% was 1.12, 23% was 1.23. So some people would think that increase by 7% is 1.7, but it's not timesing by 1.7, and you'll see why in a second. So if you follow the same logic, it would be 100% plus 7% equals 107%. Move your decimal point in two places to get your decimal, and that would leave you with 1.07. So obviously that's different than just 1.7. Exactly the same logic applies for percentage decreases. You can still find a multiplier, but the only difference is that instead of adding the percentage onto 100, like we've done here, add 12%, add 23%, add 7%, we are then subtracting 12% or 23% or 7% from 100. So for example, a decrease of 41%, decreased by 41%, your decimal, so a lot of people think it's 0.41, but that's actually wrong, as you're about to see. So you'd start with 100%, you are losing 41%, which means you have 59% left of what you started with, and your decimal, move your point in two places, or divide by 100 is 0.59. So your decimal multiplier for a 41% decrease is times by 0.59.